Okay, so we're back, and now we're going to look inside of the penis. So on the left we have X-ray vision, and we can see the structures inside the penis, and then on the right we have actually a cross section where we've actually cut the penis, what they call sagittally, where you're cutting across, and you can see those structures and what they look like inside of them. So let's label them. Okay, so if we start at the bottom of the picture, we're actually looking at the scrotum. That's the sac of skin and muscle that actually contains the testicles. It's usually covered in hair. It's gotten more popular to remove that hair anyway, but in this picture they definitely wanted us to be able to see those striations of the muscle that can pull the testicles up closer to the body. The function of the scrotum is to keep the testicles away from the body so that the testicles can operate at their optimal temperature. So ideally the scrotum should be maintained at about 97.1 or something like that. And so the hotter it is out, the more relaxed the scrotum will be. The colder it is, the more they'll pull the testicles closer to the body. There are actually a couple of times that the scrotum pulls, actually 3 times, that the 3 situations that can cause the scrotum to pull the testicles closer to the body. One is cold, and usually I try and get my students to guess this and figure it out, so I'll give you a second to think about it. What could cause the scrotum to pull the testicles closer to the body? One is when you're cold. One is when you're scared. The autonomic nervous system, when you're under fear, pulls the testicles closer as if to protect them, really. So that muscle mass just tenses up and pulls the testicles closer. And then the other time is during arousal. It's one of the ways that we can tell that the man is reaching the plateau phase, is that the scrotum has pulled really close up to the body. Okay, now if we look at the penis, we've got the purple structures, and there are actually 2. They're called the corpora cavernosa. Corpora is a plural word that means body, and then cavernosa means it's cavernous. So we've got this cavernous body, and if you look at the cross section, you can see how cavernous the body really is. Those red dots in the middle of the corpora cavernosa in the right hand picture are actually veins. I'm not a medical professional, so I don't know. I think they're veins, right? They're the ones that deliver blood. They are going to bring blood into the penis, and then during arousal, the corpora cavernosa will actually start to accumulate that blood and hold it. There's actually a little sphincter, I guess is the only word I can think of, at the base of the penis that will allow blood in during arousal but won't let it back out. And so the corpora cavernosa starts to fill up with blood. The corpus spongiosum is the pinkish body that runs along under the corpora cavernosa, and it fully encases the urethra. So it also fills with blood, but it can't get quite as full of blood as the corpora cavernosa, or else it would stop the flow of fluids through the urethra, which we need for ejaculation. So it doesn't get quite as rigid as the corpora cavernosa does. So all of the rigidity of the penis at arousal is attributable to the accumulation of blood in the corpora cavernosa and the corpus spongiosum. Okay, I think we can all enjoy the fact that on the right hand side that picture kind of looks like a face, doesn't it? Like some kind of bug or something, or an alien. But anyway, so those are the main structures of the penis that allow for erection. If you notice in the picture on the left, the corpora cavernosa extends way into the body to provide stability during erection. And there's a new treatment for, well, I don't know if treatment's the right word. There's a surgery that men could have done if they feel like they want penis enhancement. And the treatment involves basically pulling the corpora cavernosa closer to the abdomen so that there's actually less of it inside the body and more of it outside the body. Usually you have to go through some stretching of your penis skin beforehand by putting like these little balloons that are filled with water, and they put more and more water in to stretch out the skin. It's all quite invasive. And then you end up with a penis that's not as well rooted to the body as it had been before, and so it's got less stability and has a higher probability of actually experiencing breakage. I mean, it's hard to say that you can break your penis. There's no bone in it, but what can happen with the penis when it's erect, there it's encased. You can see in the picture on the right hand side there's a blue line that goes around the corpora cavernosa. That blue line is what we call fascia, and it's kind of about the consistency of like saran wrap, sort of. As the blood floods into the corpora cavernosa, that fascia is what causes the basically the rigidity of the penis. And so if you've got an erect penis and it gets bent really hard while erect, it can actually rupture that fascia and let the blood come flowing out into the area under the skin, and you can actually bleed out from it. It's a really serious thing. So when men are having sex where they're on the bottom, let's say, and their partner is on top, you don't want to have, space between your partner and your penis. You want to make sure you stay in contact, because if she or he lands hard on the penis with their body instead of their orifice, you can end up actually bending the penis so hard that you can break it. And it's a really long recovery, and it hurts like, oh my gosh. And so men who have had this kind of surgery where they pulled the penis farther out of the body are at somewhat higher risk for such a injury. So yeah, just thought I'd point that out. Okay, let's go inside the male body. Okay, so we're looking at the internal structures. Let's start as if we are a baby sperm that's going to be being developed. So we're going to start in the testicles. So the testicle is down at the bottom and it's inside the scrotum. Inside the testicles are almost a mile. It's like 3/4 of a mile long worth of little human hair sized tubes that have been wound up, all twisted and wound up in like little, they almost look like a series of little maple leaves that, and the tubules go around the fingers of the maple leaf closer and closer till they're in the center. And then what happens is that a little sperm is going to travel along one of those little maple leaves all the way until finally it's ready to move. It'll be in the center of the maple leaf and it'll get pushed up to the epididymis to finish maturing. The epididymis is, again, a series of tubes, and so the sperm moves up into the epididymis, and then slowly over the next like 28 days it's going to move down the epididymis, maturing, getting its protein pack and getting its tail growth and all the things it needs to do to be ready to be ejaculated. This is a good time to mention that if ejaculation doesn't occur, the sperm would just get absorbed into the bloodstream from the epididymis. So it doesn't build up in the testicle. It just gets absorbed off into the bloodstream. So from the epididymis, a mature sperm is then going to travel up the vas deferens. That's the tube that joins the epididymis to see how it goes up around and over the ureter that's coming down from the kidney. Goes around that, and then it's going to join up with the next structures. So the vas deferens is a really long tube. Now you might have heard of somebody having had a vasectomy. A vasectomy is when the doctor comes in, makes a very tiny little incision on the back of the testicle, or on the back of the scrotum, sorry, pulls the vas deferens out and actually cuts it, glues it, wraps string around it, whatever their procedure, whatever their method is, to prevent the sperm from getting from the testicle to the outside world. So we're going to talk about that more when we get to birth control methods, but that's the tube that gets severed. So the sperm is going to travel through the vas deferens, and with the pulsing of the muscle of the scrotum at ejaculation and the pulsing of the vas deferens, it's going to be propelled into the next stage, the seminal vesicle. So the sperm is going to be met by fluid that's been created by the seminal vesicle that's going to provide nutrition and protection for the sperm once it enters the female body. The female body is really hostile to sperm because it's not the female body's own DNA, and so the seminal vesicle provides stuff that the sperm needs to have a better chance at surviving in the female reproductive tract. This is the point when I like to ask students, what % of the total volume of ejaculate do you think is made up of sperm? And usually people are like, I don't know, 20, 50, something like that. The sperm actually account for about 1% of the total volume of what comes out during ejaculation. The seminal vesicle provides about 4% of the fluid that's going to come out at ejaculation. And then the prostate gland, which is our next structure, actually contributes the remainder. The ejaculatory duct is in the prostate gland, and it's where the sperm and the fluids from the seminal vesicle are going to mix with the fluids from the prostate gland before entering the urethra. So the prostate gland contributes the vast majority of the fluid that comes out during ejaculation. The next structure is the Cowper's gland. And this is actually, remember back in chapter 1 when we talked about the possibility of getting pregnant even if the man withdraws? One of the main culprits for why, even if he's completely certain he has not ejaculated yet, there might have been live sperm deposited into the vagina, is because the Cowper's gland actually secretes fluid prior to ejaculation. It actually lubricates the urethra to make sure that it's sort of neutralizing any ammonia that's left from the last time the man urinated, stuff like that. But if he recently ejaculated, hasn't urinated since, and then is going to ejaculate again, that Cowper's fluid might sweep along with it some live sperm that are left from the last ejaculation. And so there is a possibility, without having any ejaculation occurring, no, I waited 1 second too long to withdraw or something, none of that, but literally, I didn't ejaculate in you. How could you be pregnant? Well, if you recently ejaculated prior and then went to have the withdrawal method as your method, the Cowper's gland might be sweeping along some live sperm from last time. It's rare, but it's possible. Okay, so we've got the Cowper's gland lubricating the urethra, and then very quickly after that will come the fluid that is comprised of the sperm, the seminal vesicle fluid, and the prostate gland fluid. And we'll have ejaculation. Okay. Let's go ahead and take a small break before we deal with this interesting photograph of female external structures.